Good morning, everyone. A very good morning. Shall we begin the Shall we begin the session? Today's topic is chapter number 4, functions in C++. What are the various functions that is available in C++, how we can use that, and what are the advantages of using the functions in C++. So first of all, I will tell you that functions is a subprogram of the main program. So whenever I write small chunks of the main program, that becomes a function. For example, I want to do the calculations. That a calculation includes addition, subtraction, division, multiplication. So instead of using each and every function or each and every function of the calculation in one place, I will put up in the different function. That means I will put up at the end, there is addition function separate, subtraction separate, division separate, multiplication separate. So this is the main use of the function. That means to not to make the program hodgepodge, or we can say the not to make the program flimsy. We can use the function so that it will be used another words. That is the functions in C++. Yeah, that is a subprogram of the main program. So we know that the functions plays an important role in the C also, and dividing the main function or the program into the function in one of the major principle of the top-down approach, structured programming approach. Another advantage is that it is possible to reduce the size of the program by calling and using them. As I told you that we can reduce the size of the program because if in a main program only the line will be given instead of giving the full definition. Only the line will be given for the declaration. The definition is given at the end of the program. Is after the int main. So recall that we have a syntax similar to the following C program. This is the function declaration, function calling, and the function definition. So declaration is also known as the prototype, calling, and then there is a definition. This is the function body. And whenever a function is called, the transfer is or control is transferred to the first statement in the function. The other statements in the function body are then executed, then control returns to the main program. That means whenever we use a function, that direct cursor goes to the main program. Cursor goes to the definition of the function. It will be executed, and then again the control returns to the main program, and the closing braces are encountered. As C++ has no exceptions, functions continue to be the building blocks of the C++ program. And in fact, C++ has many added features, many new features to the functions to make them more reliable, more flexible. And like C++ operators, our C++ functions can be overloaded to make it perform different tasks depending on the arguments it will proceed to. And most of these modifications are aimed at meeting the requirements of the object-oriented facilities. And in this, we are going to discuss with the various new features that are added to the C++. Next part is a main function, that is the int main. So the C does not specify any return for the main function, which is the starting point of the execution of the program. But int main is used in the C++ because we defined as main function as matching one of the prototypes, that is either int main or int args, km, argv. So these functions have a return type that should return the statement for the termination. And this main function in C++ is therefore defined as follows: int main return 0. And since the return type of the function is int by default, so the keyword int is a main header optional. That C++ compiler will generate an error or the warning if there is no return type or return statement. And also therefore C++ issues the warning that the function should return a value and proceed to compile the program. And it is a good programming practice to actually return a value from the main. Because when we return the value, there is the exit value to determine if there is any problem, and the normal convention is that there is an exit value of the 0. That means the program ran successfully, that is used with was a no problem. And the explicit use of the return 0 will also indicate that the program was successfully executed. Yes. So when I compile all these things, so in these paragraphs, it is only said that there are three parts of the function: function prototype, function declaration, and the function definition. Prototype is given above the int main, below the header files. Declaration is given within the int main. Definition is given after the int main. These are given within the int main. That is a good practice to actually return a value from the main. And most of these will return a value to determine if there is any problem, if there is any convention, that is the exit value of the 0. And int main returns a 0 because we are supplying the return type int. So when we supply the return type, so it is mandatory to return any value, so we return the value as a 0. Yeah, function prototype and the declarations are terminated with a semicolon, but the definition is not terminated with a semicolon. This is the main difference between the declaration, definition, and the prototype. There is no semicolon. Yes. Okay. Now the next part is the function prototype. That is one of the major achievements, improvement that is added to the C++ functions. So prototype describes a function interface to the compiler by giving the details such as a number and the type of arguments it is using and the type of return values. With the function prototypes, a template is always used when declaring and defining the function. The template in the sense, there is a return type, there is a function name, there is an argument list. And when a function is called, that means a declaration, the compiler uses the template to ensure that the proper arguments are passed and the return value is treated correctly. Any violation in matching the arguments or the return types will be caught by the compiler at the time of compilation itself. So whenever it is using the compilation, it will caught by the compiler only, and these checks and controls that did not exist in the conventional C function because it is used with the function prototype. And remember that the C also uses the prototyping, but it was introduced first in the C++ by the Stout step, and the success of these features inspired by the NSI. So this inspired the NSI committee to adopt it. However, there is a major difference in prototyping between the C and the C++. And while C++ makes the prototyping essential, so NSI also makes it optional. Or perhaps it will be used with the compatibility with the classic C. This is the declaration, type, function name, argument list. So this argument list contains the type and the names of the argument that must be passed to the function. So example includes float volume int xyz. And note that each argument variable must be declared independently inside the parentheses. That is, it is a combined declaration like float volume int x, float y, and the z. That is again the illegal because we are declaring only the two. Yeah, we are initializing only the two variable with their data type, but we are not considering the third data type that is very much essential in the prototype. Declaration it is okay, but in prototype it is very much essential. And in a functional declaration, the names of the arguments are the dummy variables and therefore they are optional. That is the form float volume int float float. It's acceptable at the place of declaration. At this stage, the compiler only checks for the type of arguments when the function is called, only the type it belongs to. And in general, we can either include or exclude the variable name in the argument list of prototypes. That is, a variable name in the prototype will be called just as a placeholder, and therefore if names are not given, if names are not considered out, they will not proceed with the how the placeholder will be given, how they will be used to match the names in the function call of the function definition. And in the function definition, the names are required because the argument must be referred inside the function. Yeah, volume is the main function that will be called. So float cube 1 equals to volume v1 w1 h1. That is the breadth, width, and the height. And the variables are known as actual parameter, which specifies the dimensions of cube 1, and their type, which has been declared earlier, should match with the types declared in the prototype. And remember that the calling the statement should not include the type names in the argument list. We can also declare a function with an empty argument list. So void display, only display. And in C++, this means that the name or the function does not pass any parameter. It is identical to the statement. Void display void. However, in C, an empty parenthesis implies any number of the arguments. That is, we have foregone prototyping, and the C++ functions also have an open parameter list by the use of ellipse in the prototype, that is as shown over here. So this is void do something. Next is call by reference. So whatever the parameters we have, whatever the parameter we have passed, that is passed by the value, that is called by the value. But whenever we are using the call by reference, these are functions that creates a new set of the variables and copies the value of the arguments into them. The function does not have access to the actual variables in the calling program and can work only on the copies of the values. And this mechanism is very much fine because the function does not need to alter the values in the calling program, but there are the condition that may arise is when we would like to change the values of the variable. For example, in the bubble sort, when we compare the two adjacent elements in the list and interchange their values, if the first element is greater than the second, that is also used for the bubble sort, that it should be able to alter the value of the other variables in the calling function, which is not possible if the call by value method is used. And provision of the reference variable in the C++ permits us to pass the parameter to the functions by reference. That is, it will be used with the formal arguments in the called function in the calling function that becomes alias to the actual arguments. So there are two parts, actual arguments or the formal arguments. Actual will be used to introduce whatever the functions we are introducing, whatever the arguments we are introducing in the calling function. This means that when the function is working with its own argument, it is actually working on the original data. This is one of the swap program, void swap int ampersand a, int ampersand b, int t equals to a equals to b equals to t. Yeah, whatever the variable they are using or whatever the value they are using of, they are declaring the values with the ampersand a and the b. Now, if m and n are two integer variables, then the function called that is swap mn are used as an alias name that is returning or that is used with the function that is used with the value that will be generated, the output that will be generated, the input, arguments, function calling, main program, and so on, so on, so on. So there are multiple procedures that will be carried out with this. But instead of using the call by reference, if I use call by value, whenever there is a change, that changes will be reflected back in the program. Yeah, there may arise situation when we would like to change the values of the variable in the calling program. For example, in the bubble sort, we compared the two adjacent elements that will be given to interchange the values that will be interchanged for the bubble sort. Then it should be able to alter the value of the variables in the calling function, which is not possible if the call by value method is permits or used. Alright. This is how we can pass the value by the reference. So there are two parts, one is the calling program and the call program. Yeah, this is called by reference. Another one is called by value. So there are two parts of this that I'm going to take within the next class. That is, what is the difference between the call by value and the call by reference? Yeah, it is totally different. That is, what is the difference between that? How we can change them? What is the main motto behind the call by value and the call by reference? that I'm going to consider within the next class. So that's all for today's session. If there's any doubts, any clarification, you can ask the doubts, you can clarify the doubts.